So, welcome back to my channel, Logic Unlocked. What's the smallest substring that contains all letters from a target string? That is our Leetcode 76 minimum window substring. Is a famous sliding window plus hashmap pattern. Let's crack the logic step by step. We count what characters we need from T. Okay. Uh, then we move a window in yes, adding characters until all requirements are matched. Once matched, we shrink the window from the left to find the smallest window that still contains all needed letters. It's like collecting puzzle pieces and then throwing away the extras to keep the core. So what makes it hard? Handles repeated what characters, making sure we track exact count, efficiently shrinking window without missing any requirement. So it would be like hashmap to it. We will be using hashmap to count need and move right pointer to expand window. Check if all characters are matched. Move left pointer to string the window. Keep updating smallest window found. Here in the example, you can see S is equals to A, D, O, P, something like so many kind of letters are there here. From this, we need to remove meaningful matching letters. That is T is equals to A, B, C. So window will be like until the matches, we'll be going on, going on. Then we'll be shrinking the remaining whenever we find A, B, C. That's what. And B, A, N, C is the smallest here. Okay. B, A, N, C till here to here, it is the smallest. So we will be seeing the intuition. This question broke my brain for the first time I saw it. Literally. Given two strings yes and t, find the smallest window in yes, which contains all characters from t. And let's break this down with real intuition and cleanest sliding window trick. That is, think of a string S as a long paragraph, and string T as a set of letters you're trying to highlight inside that paragraph. If you imagine this, it would be easy. You want the shortest possible section of the paragraph that contains every letter from T. No more, no less. So we need to move the window 2 pointers over the string. We expand the window until we have collected all the required letters. Then we try to shrink it from the left to make it as small as possible, but still valid. It's like trying to grab all in the ingredients in a basket, then remove the extras while still keeping everything you need for the recipe. Logic is like first I count how many characters I needed from T. Then I move the right pointer through the string. Yes, that is here we can see. Next, next, adding characters to the current window. When my window has all characters in required counts, I try to shrink from left to minimize the window. I try to shrink them from left. Why? To minimize them, because I can't keep everything, right? If there is no stuff that I need, then I'll start shrinking it. Then every time I find a valid window, I check if it's smaller than if is it smaller than the previous best and update it. At the end, I return the smallest valid window found. Let's try run it. For example, let's consider this thing and this thing as yes, and this is as t. Now we need A, B, C from yes. Okay, we keep moving right until we have found A, comma B, comma C. Now we try to shrink the window. Eventually, we land on B, A, N, C because here is a this is a part where we have all the things. We have A, we have B, we have C. Okay, and that is the smallest part overall the yes string. Okay. Okay, till here it's okay. I use two hash maps. One to count how many characters I need from it, from T. Another to track the characters in my current window. So obviously, I'll be running two stacks. Okay, I've told you the what is the need of that. And next, as I move right, I add characters to the window. As long as I move the pointer right side, I will be adding the characters to the window. Then the window becomes valid. I try to shrink it by moving left, as I said you. If the window becomes invalid, that is a missing character. I stop shrinking and expand again. That means I'll be moving right. Okay. If I didn't find that, I'll be moving right. Next, it's like this. This keeps repeating until I finish transversing yes. It's like this question is a perfect combo of logic and optimization. The first time feels hard, but once you get the sliding window pattern, then you will track similar problems in seconds and count what you need, expand till you meet the need, and shrink till you break it. That's it. This is a thing what you will be doing in this code. Look at into the code deeply. So if we can see it here, it is checking whether it is empty or not first way. And if it's empty, then it's the edge case you can use. Whether if it is empty, then return. Okay. Next, it is taking an unordered map here. Okay. We are using two hash maps, which collects the characters and the int, and needs to store how many times each character in T is required. It will be storing. Okay. It will be storing the need. Window stores how many times each character is currently present in our window of yes. This will be storing it. That is a window. We are naming it as a window. It is storing the need. This hash map is storing need. Next, here it is like for. Let's see the for condition. Character to T need increase the need. So build the frequency map of string T. So T is equals to A, B, C, right? Then need is equals to A to B is to 1, C is to 1, for example, if it is like that. So that's the thing. Need will be increasing as the character will be there from T. If we found a character from T, then increase the need. Okay, that's it. That means update the need hash map. Next, here it's like have tells how many unique characters we have already satisfied in the window. This is that have. Okay. Next, need size is total. It is the total number of unique characters we need. That is size of the need map. That is T is equals to ABC. So we need three unique characters. Need size will be three, as we will check in this example. Then we'll be knowing it. Next, left pointer. Left is like pointer of sliding window. Minimum left is like to track the smallest window so far found. Next, minimum start would be like stores where that start smallest window starts. It will be storing that. Next, for the for loop, it is like standard sliding window, expanding the right end one character at one time. It will be expanding the right character as we did not find this. Okay. Next, right character at one time. And the next one would be this is the key logic actually. We check if the character is part of the requirement or not. Is it in the need or not? Need that count. We'll be checking. And if we now have just enough of it, then window of C is equals to need. Then have plus plus we'll be doing. Then we say one more requirement is satisfied. We'll be increasing the have. So we so how so have tracks how many required characters are fully satisfied. Next, this means this while condition means all required characters are satisfied in current window. So we try to shrink the window from left to see if we can make the smaller and still valid. Yes. And this condition is like if the current window is smaller than the previous smallest, update the result. We store the minimum start and minimum end length to return later. So that's the thing. Next is like this one. Try to shift shrink from left. It's like shrink the window from left. Remove yes of left from the window map if it is we did not find it till here. Then another need is like after removing a character from window, if it's a needed character and how we do not have enough of it, then we'll be doing have minus minus. Like because now the window is no longer valid, we break the while loop and expand right again. That's the thing. Next, to expand the right, we'll be moving left ahead, left plus plus. Next, and to shrink the left and move the pointer towards right, we'll be doing left plus plus. Finally, if we found a valid window, return the substring, else return. That is this. Like if no window valid was found, else return. That's it. We expand right until required characters are matched. Then we shrink from the left as much as possible while still valid. At each valid window, we track the minimum. We use two hash maps count required and current characters. The have is equals to need size. Condition helps us to know when we have a valid window. This is a thing that's happening inside this code. Hope you have understood. If not, just go back and listen once again. I'll assure that you'll be understanding it again. Okay, very simple, but little complicated because we need to express it in a. We'll be using hash maps and we'll be doing it. So make sure you just understood this. Thank you so much for watching.